Very good afternoon, one and all. First of all, after the enlightening thoughts from the Dr. Chandan Kumar, from the Professor M.K. Verma in the inauguration session, now with this lecture we are going to start this event, right? This faculty development program. So, with the theme of the program, I have designed this first my session based on the introduction to intelligent computing and its application in healthcare. So this is given just to give you the idea about what is intelligent computing and how it is going to be implemented in the healthcare. What are the ways and what are the benefits? So this will be a foundation for all your coming lectures. So with that intention, this lecture has been designed. So without wasting my time, as everybody knows about me, I would like to now start my presentation today. Yes, what do you understand by this intelligent computing and its applications in healthcare? Why it is possible nowadays? And the reason is that the way the digital computers has been actually evolved, and as they are being used for the automation of many tasks, not only the healthcare. There are many tasks which are actually being conducted by the human beings. These digital computers are able to give an assistance to them, to the human beings, right? So how it is possible? Because in two ways that automation is possible in two ways. First one is the direct mapping of input and output. Okay, and the computer in that case is programmed to continuously follow the specified instructions. Okay, so where we know that for giving this output, we are going to receive this output based on the mathematical model that has been actually prepared, designed and developed in that for that computer, right? So this form of problem solving is viewed as lacking, is a conventional one, but it lacks some intelligence. This is very important, and here the role of intelligence comes. Okay, the need of intelligent programs to tackle real life problems was a major challenge, and this has been actually understood by the scientists in the year 1950s, right? During this period, actually, the scientists were trying to do some researches in the interdisciplinary fields, and that research has ultimately cultivated into the another field of research that is called as artificial intelligence. Okay, what is the main goal of that AI is to automate human tasks that require intelligence, such as pattern recognition, machine translation, computer vision. Means, say that you want to recognize something on say on image, if you want to recognize the voice of some particular person, if you want to identify some picture. Okay, so that task is actually need to be that sort of task requires an intelligence. Okay, the human intelligence cannot be the human cannot continuously monitor, recognize all that patterns manually. There is a requirement of some automated methods, and with view of that, the artificial intelligence is nothing but mimicking the human intelligence by the computers. Okay, that is what exactly is actually developed during that time, 1950s, right? Now, next thing comes into our mind, that what is intelligent computing. So intelligent computing basically that developing the artificial intelligence scenarios or artificial intelligence designs for not only artificial intelligence but assisted with the big computer analytics or computer networks. Okay, and then so that we can sense, analyze, evaluate and predict the environmental parameter in the real world. That is what is called as intelligent computing. Means, for whatever the problems that we face in day-to-day life, putting the artificial intelligence along with the big data analytics and the computer networks, whatever the artificial intelligence will be used and the task will be performed automatically. That is what is the purpose of intelligent computing is, right? So when I say intelligent computing, it actually it installs distributed intelligent network, which includes devices with the ability of sensing, communicating, and information processing. So this you have to understand. Whenever you design any AI architecture, there are basically two things. First one is the environment, and second one is the agent. Agent is nothing but the AI, that is the artificial intelligence computer programs which are actually learning from the environment. So from the environment it will be learned by using sensors, and it will also deliver output to the environment as well in the form of the actuators. Okay, so it means that we need the first ability of sensing, communicating with the environment, and whatever the information that has been received from the environment to process that environment. That ability is required for doing the for developing the intelligent computing systems, right? So these devices, basically sensors, communication, and the processors, they work together and share resources and information with the help of communication network, right? So based on pervasive computing, which is human oriented, basically this intelligent computing is actually designed. Now as I told you earlier also, that when I say artificial intelligence, it is nothing but mimicking the human intelligence, right? That is what is we consider that by using that that artificial intelligence, whatever the computing that we are performing, the way the human performs or human brain computes, okay, that is the main motive. That is the basis of the intelligent computing. The objective of the pervasive computing is to achieve effective combination of the information space, physical space, and making computing devices and computing service everywhere. That is what is expected everywhere. Like, let me give an example of some. You say that you are having an intelligent car. Okay, the car actually senses, and there is a AI based system is there, and that AI based system, according to the sensor's input, takes a decision to divert from right to left or left to right automatically. So that sort of that. So for doing that, it requires information space, physical space, then computing devices, okay, and computing service everywhere, right? So when I talk about intelligent space in intelligent computing, where what does that mean? It is the actually space where the system automatically completed the information collection, analysis, processing, and evaluation. You have to understand here that the data is going to be sensed, it is going to be analyzed, okay, it is going to be processed, and then it is going to be evaluated. That all comes under the intelligence space. Once you have that intelligence space, or we can say that if you go to the scientist or researchers levels, we call it as a AI system, and which is having the agent and the environment, right? This generally actually refers to ability of the system to gather some knowledge from the data and from the data or the experiments, right? So that is what is the meaning of the intelligent space. Once you have that intelligent space, okay, that your intelligent computing systems can automatically sense the environmental changes in the sensor network, make judgments, and do the prediction on the environmental status time, and provide response strategy in different environments, applying pattern recognition, time series prediction, big data analytics. By using all these technologies, it will be able to provide you the prediction, it will be provide you the responses. Okay, say that just like I told you about the smart cars where they actually senses. So say that there is infrared camera is there, that infrared camera is capturing the picture of the coming vehicle just in front of that particular car. Then what will happen? That that infrared, that picture will be captured by the camera, that image will be processed, the information will be extracted from it, okay, and it will be then given, it will be then given to the agent, AI agent, and the AI agent will, based on that, whatever the information gathered, okay, it will have some intelligence inbuilt in it based on the prior knowledge, okay, past experiences, and based on that, it will be taking the decision on the inputs that yes, if this is the, if that particular vehicle which is coming from the front side, if it is at this distance, or if it is coming with this speed, then you have to apply a brake, and that brake, that pressure, or how much that brake you need to apply, it will be decided by that intelligent system. So this is how actually the intelligent computing system works, right? So now we have to understand that what are exactly the benefits of this intelligent computing. First, it is in conventional computing, we are very sure that we are having the guarantee that a solution to a given problem, because I know that if I'm giving this input, I know that according to that mathematical model, this output is going to be generated. Okay, so the solution is guaranteed there. While in case of intelligent computing, the computer has to learn. Okay, it has to take the decision on its own intelligence, on its own intelligence. So sometimes it happens that it is not always necessary that it will be guaranteedly giving you the solution of a problem, right? Second thing is that in conventional computing, the results are reliable and consistent, while in case of intelligent computing, results may not be reliable and consistent. Okay, so that is why this intelligent computing is still a thirst area, and people are working tirelessly into this to make it more reliable and more consistent. And I can tell you, with this, in the present era, the status of this intelligent computing is improved a lot. The consistency and the reliability is now increasing. If I can tell you that earlier, means we putting these things, putting the intelligence, artificial intelligence into the applications where the human lives are involved, were not actually accepted. It was not welcome. But now, with increasing reliability and the consistency of its performance, it is now gradually getting accepted, right? And the third thing is that the programmers in the conventional computing tells the system exactly how to solve the problem. While in case of intelligent computing, programmer does not tell the system, because in this case, the system will, on its own intelligence, will be solving the problem. Okay. Second thing is that in conventional computing, it can solve only one problem at a time in a given domain. While in case of intelligent computing, it can solve problem in a given range of problems. Because what happens when as I told you about that car, it will be applying the brakes also. It will be showing some indicators also. It will be also giving an alarm to the driver also. So it has to perform many problems at a time, because it needs to act like a human, right? So we know that human, say that if you are seeing some car coming, some vehicle coming to your car, so you'll be doing some actions, right? And that will not be a single action. It will be multiple actions, right? You'll be buzzing the horn, you'll be showing the hands, or you'll be applying the strong brakes as per your understanding about the situation, right? So you'll be doing the multiple tasks at a time. So in this case also, it is expected that the intelligent computing need not to only perform one operation, but it may need to perform more than one operations at a time, right? So what are the applications of the intelligent computing? There are many. Means if you will see the present era, it has applications everywhere. We have the intelligent air conditioners, we have the intelligent washing machines, we have the intelligent cars, we have the intelligent uh, uh, right, healthcare systems are there. Okay, there are intelligent transportation, as I just given you an example. There is a intelligent decision support systems are there, where actually you uh, uh, like one in the share market, it actually takes the data and intelligently it suggests or it predicts that what is going to rise into the next coming 7 days. Or there is a weather forecasting, there is a load forecasting systems are there, which are based on the artificial intelligence, and they provides you the intelligence support, decision support. Okay, for deciding that how much load you have to put on that day, or how much presence of electricity, or you can give an alarm to the uh, uh, concerned authorities to be ready, prepared, to be prepared for the storms, for the rain, right? So there are many such applications, right, related to humanistic intelligence. Then there is a environment monitoring system, as I told you just now. Data mining problems are there, information retrieval is there, right? That you're trying to retrieve informations, okay? Then the detection of the regularities, okay? So these are many such applications are possible with intelligent computing. Now, what are the advantages of this intelligent computing then? As I told you that there are in the previous slide, I said you that reliability is less, there is a consistency is less, but yes, above even with those limitations, it is having the advantages, like it is more powerful, it is more useful for the it will make your computers more useful. Okay, new and improved interfaces are there. Now people are having the new and improved interfaces are designing, and due to that, many more applications and the scope of your intelligent computing is increasing. Then there is a better handling of the information, organized way, right? All the information that is coming by the different sensors are going to be precisely measured, processed, then the information will be extracted properly by the computers. Then it relieves the information overload, right? Whatever the information overload is there, that also can be handled very easily in the intelligent computing. That say by doing some your dominant features extraction or principal components extraction, so that whatever the information overload is there, that can be relieved, right? So we can reduce that size of the informations by using some methodologies, technologies, right? Then conversion of the information into the knowledge. So this is very important, where we say that whatever the information is coming, right? Images are coming and signals are coming. That is all information, but we have to convert that into the computer knowledge. Okay, so we'll be extracting the useful features, okay, from those machine from that information, and that only will be used for developing the intelligence, artificial intelligence or the computer intelligence, right? Now, yes, as I told you already that there are disadvantages, but addition to that, there is an increased cost, because we have to involve the computing machines here. We have to involve the expert programmers, right? Scientists need to be involved. Their resource costing is very high. The difficulty with software development, and it is possible because it may be slow, expensive, because need to handle larger data. You have to design complex programs. So that makes the things either slow or maybe sometimes very expensive. You have to procure, or you have to make available the computers which are having the ability to handle that complexity in the data, non-linearity in the data, okay, and the programming, okay. So, and there are the programmers. As I told you that the experienced programmers are very less, the experienced one. Okay, those who can handle the things in a very way. That's why if you will go to somebody, say, automation industry, you will see that there will be principal scientists who will be giving you the exact on the basis of the experience, he will be sharing or giving his advice or supervising the designing of the AI systems. Okay, so those kind of people are very less in number, right? Few practical products have reached the market as yet. So that is the reason why because of all these disadvantages. One more thing is that even we are working a lot in this field, but there are very less number of systems, intelligent computing systems are available in the market, right? But yes, it is growing day by day. Now I must say that it is increasing day by day, and sometime if you'll just look at this graph here, which I have shown here for the performance over time, if you just see the human performance and the computer performance, it has started at a very lower part, but now it is increasing, and we are somewhere here now. We are somewhere here, and we are now almost with the increased ability of the computers to handle the nonlinearity of the data, information processing, larger data sets, and the ability of the human beings or ability of the experienced programmers to design the complex programs. We are going to cross this about the human intelligence, and sometime in future you will be seeing that the computers will be building its own intelligence on its own and performing the task, taking the decisions, solving the problems on their own expertise. So that is how the systems will be there in the future, right? So if you will see here, we are just approaching towards the point or the threshold where our artificial intelligence is going to be better than the human intelligence, right? So let me just tell about the artificial intelligence. It is actually the term coined by McCarthy in 1956. What artificial intelligence means? That yes, we, with the help of the programs, with the help of the information, we are building an intelligence into the computers, right? Just the way human has. Okay, so it is an ability to acquire knowledge or and use it or relates to the task involving higher mental processes, right? And therefore, AI is the study of ideas that enable computers to be intelligent. It is a part of the computer science concerned with the design of computer system that exhibit or that mimic the human intelligence, right? So from the two about definitions, these are the major roles that you need to understand. First role of the human beings while designing this artificial intelligence is to study the intelligent path, okay, concerned with the humans. And second part is to represent those actions or those human intelligence using computers. That is what is the main two things that we need to perform for developing the artificial intelligence. What are the goals of the artificial intelligence? What do we want? Yes, we want that the computers get more useful. They starts to get assist reliably and consistently to take over some important task. I will say important task, not dangerous or tedious, but I will say important task. Like say that in healthcare, where we are actually related to the human lives of the human beings. Okay, so it is very sensitive area where we need to apply that artificial intelligence in such a way that it can be very much reliable. It is very much consistent, and it can assist the medical practitioners to take decisions to reduce their load. Okay, and we also expect that from the AI, we will be able to understand the principles of the human intelligence. That is what is expected. That yes, if you are able to recall earlier that we used to have that neural networks. We used to consider it as one single neuron. Neuron is nothing but that is what we used to consider it as a human brain neuron, right? And we have designed one activation function, and we are considering that it is a replica of the human brain neuron, and it will perform the action similar to the neuron, right? So that action, we have to understand the principles of the neurons and the way the information is propagating from one neuron to another neuron, and how that information is actually being transmitted from one place to another place in the body. If we understand all that things, accordingly we can improvise our artificial intelligence techniques, and that is what is expeditiously going on in the present time, right? Yes, as I was telling you, that AI system is having basically two important components. First one is the agent and second one is the environment. This agent actually learns from the environment. You can see here, these are the arrows. These are indicating that it is learning from the environment. It is developing the abilities. It is also fed with the goals and preferences. Goals and preferences are nothing but the ground truth. That yes, if I want to learn, if I want to make learn a newborn baby about a ball, so I'll be showing the pictures of the balls to the baby. Say this is a football picture, then I will show the cricket ball picture to that baby, then I will show some another ball picture to that baby. With those pictures, the baby will understand that yes, something which is circular in nature is called as a ball, right? Then I will perform some actions. Okay, I will bounce one circular things on the I will bounce the circular things on the earth, okay, on the floor, and if it is bouncing, then I will say that yes, it is a ball. But if I'm taking some, say that some laddu, okay, and it is, even though it is circular in shape, but when I'm trying to bounce it on the floor, it will not bounce. So I will mention that this is not a ball to that newborn baby. So the baby will understand that yes, everything which is circular in shape is not a ball. A ball is something which is circular in shape and bounces from the floor. It is called as a ball. So this is how the system learns as well, right? So there will be some goals given to that. You have to give the goals. So whenever I am giving the information about the ball, I have shown the picture and I told to that baby that this is a ball. I am giving this goals, okay, to understand that baby that this is a ball, okay, and that is how it is learning with that goals. So this is the prior knowledge. Prior knowledge you have to give as an input to the agent, and agent will also have some its own observation, past experiences, and based on that, based on the intelligence developed by that agent, it will be taking the actions, and that actions will go to the environment, right? So this is how the total AI system works. Now, let me go to the next in the details of the AI systems. If you just look at the AI, earlier AI systems started in the year of 1950s, and it is if you will see the growth until this time, this growth is actually shown on this timeline here. You can see earlier the AI was considered as it was just giving an excitement. People have started using the neural network, started to develop some small networks using those neurons. So that was an era where 1950 to 1980. But after that, the machine learning comes into the picture, which has given the further enhancement to that artificial intelligence by making the machine learn for developing the intelligence. Okay, so that is where it has started in the year 1980s, and it has still going on. And in the 2018, its further better version came, and that is called as deep learning, which is very popular now and it is most widely used. The reason of that, I will brief you or explain you the reason of that. But if you look at the timeline, it is now the present timeline. It is most widely used is the deep learning networks, right? So you can see in this timeline, initially we were just trying to say about the intelligent machines and programs, trying to develop those things. Then while doing that things, we were not having the ability to learn our computers, but that ability started developed from the 1980s, and it is further now enhanced or increased, because see, for developing the intelligence, it is required that the machine must learn from the data, from the information. It must be able to convert that information into the knowledge. That is what is the learning is all about, right? And that learning is very important here. It is the core part of the artificial intelligence. Without learning, the intelligence cannot be developed, right? So what in conclusion, I would like to tell you a few things about the AI. AI is a very diverse field, I must say that, and that is why many researchers are working in this area. It is an interdisciplinary in nature. It is not, we cannot say that based on the applications of the AI that this field has become totally interdisciplinary. I told you about the sensors. I told you about the communication network. It requires communication network. It requires sensors. It requires actuators, okay, to communicate with the environment, right? So the research is going on that part also. The research is going on the designing the agent part also. In the agent part also, people are working on developing the abilities to developing on the machine learning algorithms, deep learning algorithms. People are working on improvising the uh, uh, improvising the information processing. People are working on the deciding on the goals, preferences, right? So it is a very huge field, right? If you will see the researchers involved from the different fields, you will find the mathematicians involved here. You will find the computer science scientists are involved here. You will see, as per the applications, it is used in the mechanical, electronics, electrical. Majority of the fields are using it right now, right? So intelligent task, mimicking the intelligent task can be achieved through by different connectionism. First, that is very important to understand. And what that connectionism is that it is actually gives you about the idea about the model. That model is actually able to mimic the biological information processing unit, and that is what we have learned in the neural network, and we call it as a function or the neuron which is able to develop the or mimic the human cognitive function, right? And this model is based on the connectionisms, consists of four main parts. First one is the processing units. Yes, your data will be taken and the data will be processed. Okay, the data will be processed using some weights that you are assigning or doing some applying some convolution filters. Okay, and after that it will be given to the activation functions, which will be performing the task of the neurons or the cognitive functions. Then there will be connections and connection weights are there. So bringing all these four components here, the connectionism is installed into the AI systems. The first attempt of the AI community was to understand how information is being processed. This is very important, right? And if you will just see the engineers, majorly those who are working in this area, like from electrical and computer science and IT industries, they are majorly working on this part. Okay, they are trying to see that the information is being processed successfully, and it should, and how you can learn your that network to mimic the process. That is what exactly is the important part of your system. The resemblance of AI and artificial neural network to biological neural network, which has been actually made in the year in the era of 1950s, that has made an ideal tool to use mimicking tasks performed by intelligent agents. So from that era, people have started working. Let me just tell you about in that era when people have started using the artificial neural network. If you are able to recall, that time we used to have only single hidden layer neural networks. Okay, we were having limited linear functions. The non-linearity data was not able to handle by those networks. The networks were not able to learn deeper. The reason was that it was not able to learn the non-linearity in the features. It was having that time. It was the lesser computational ability of the computers was also limited. That was also limiting the growth of the artificial intelligence. Second thing is that yes, for developing any intelligence, you need to require a lot of data that you have to use to train the network, right? If you want a better intelligence, you have to give as much data as possible to the network to train itself. Okay, and that is what exactly is happening in the present time, that is in the deep learning time, where we can provide larger data. Okay, because we are having the larger data storages with us, we are we are having, due to that larger data storage, now if you see, we are able to capture many images, we are able to record many data, and we can store that, and we can give it to our computers and to our programs. Okay, that is possible now. Even in that era of the 1950s, the scientists were aware about the deep learning. They were having an idea that if I increase the hidden layers, this new neural network is going to learn better. It is going to learn deeper knowledge into the input data. But the problem was that that much data was not available, that much computational complexity was not able to handle by the computers. The programmers were not able to design that sort of intelligent programs that time, and the non-linearity of the data was the science behind handling the non-linearity of the data was not developed, and due to all that limitations, that deep learning was not that deep learning did not become popular in that time, but now it is becoming popular because all that limitation is now overcome in this time, right? So let me just come to the part of that very important part, that is deep learning. So why I'm talking about directly the deep learning, yes, as I told you that it is a part of the machine learning, but if you see now the present time, nobody is using the conventional machine learning algorithms. The reasons are there. The reasons are there. Okay. The reasons are that in the conventional machine learning, there is a feature extraction is involved. There is a total huge feature engineering is involved, that whatever the input data is there, from that input data, you have to extract the useful features first, dominant features. And that feature engineering itself actually captures a lot of attention, a lot of expertise required for that, a lot of experience is required. Okay, say that I am able to recall my earlier days of applying this machine learning and everything. As I was not experienced, I used to consider that yes, for images, this much, these features will be good enough. Okay, entropy and that, this simple features I used to call, apply for my one-dimensional signal, and I used to apply it. But the results were coming very poor, right? So it means that whatever the feature engineering is ever involved, that feature engineering requires two things. First, we must know that what features we need to extract, and experienced person, the experienced data scientists need to extract those features efficiently, precisely, and that data scientists also need to ensure that those features do not lose. There is one is the feature extraction, one is the feature selection. So we'll be selecting the features. So that selection of the features, he need to design very intelligently. And if any mistake happens on that part, your total system's performance is going to down, right? And due to that, this conventional machine learning is nowadays, nobody is using it. The reason is that, as I told you about the feature engineering. But if you go to the deep learning doesn't involve any feature engineering. Manual feature engineering is not involved at all. You just have to give your raw data to your deep learning algorithms. It will learn automatically from that inputting raw data. It learns automatically. It doesn't mean that it learns anything random, right? As you are able to give larger data, it actually correlates between the different information available in all the data. And it learns the features in a hierarchical way. Hierarchical way in the sense, it will learn first low level features, then medium level features, then high level features, and then after that, it will use those features to do the intended task. That is what is the advantage of the deep learning. That is what is the advantage of the deep learning. You have to understand this. You can see here this total feature extraction and classification, or whatever the task that you want to perform, it will be performed by the deep learning on its own. It doesn't involve any feature engineering, manual feature engineering is there. So due to that, what is happening here? Computer doesn't require any specialized experienced data scientist to do the task of feature engineering at all, right? It just requires the input raw data and the ground truth about related to that raw input data. Means what is that input is all about? Means it is a picture of the ball. Which ball? Football, cricket ball, everything that with that information, with that goal, or with that ground truth, it will take the input data and it will train itself to recognize, to understand that data, that information. And once it is trained, then for any test or for any random input, raw data, it will be able to predict whether it is a car or no car, right? So that is what is the advantage of the deep learning today, right? So this is, if you'll see the 1980s era, the neural network was having majorly one hidden layer, as I told you, but now it is not having, it is having multiple hidden layers. There are multiple stages there where we actually learns the feature from the input images. Like, see, this is the one input image given here to this network. We are identifying in the first layer, we are identifying just the edges. Then in the next layer, we are identifying the combination of the edges. Then in the next layer, we are identifying the features. You can see here, the eyes are nose, the lips. This has been identified from these images. And after that, this image is recognized here like this. Okay. So this is identification of the combination of the features will be performed at the output layer. So this is what exactly is happening in the deep neural networks, right? Deep learning, right? So this is a era of deep learning. Now, if you will see, a lot of people, scientists and my students ask me about this. That's what is the relation with the data about this deep learning? This big data analytics, this all come, data mining, these subjects came because today in the present time, we are able to store larger data. We can create larger data sets, and those larger data sets, with that larger data sets, the performance of our learning algorithms is increasing. If you see, the traditional machine learning algorithms were having very poor performance, but with the deep learning, or if you see the smaller neural networks, it is increased, and with the deep learning now it has increased to such an extent. You can see the performance now, and due to that only, as I was telling you earlier, the intelligent systems are becoming more reliable and more consistent now, right? So that is the relation of the data with the deep learning. So you have to understand, all the present scientists here or the budding researchers here, you need to understand, for applying a deep learning, you have to focus on your data. Okay, if you have a large data, just go ahead with the deep learning. If you don't have a large data, if you have a small data, you have to increase its size by some means. There are nowadays there are data augmentation techniques are also available, which can convert your small size data into the larger data size. Okay, just by creating the replicas of your small data size replicas, in the sense, it will not just be copying the images, it will be creating its different variations, flipping it, then if there's some noises is there, making it blur, all that things, those augmentation can be done on your data, and you can increase the size of your data, right? Now the question comes in our mind that how the deep learning works. It is very just the way you have learned in the neural networks. It actually do the computations through the network is called forward propagation. I will not spend much time on this. Whatever the input and output layers are there, we call those visible layers. Input layer is actually giving you the raw data input, and the output layer will be giving you the prediction or the classification results, right? Yes, another process, that is a back propagation algorithms are used, where we actually calculate the errors in the predictions and adjust the weights and the biases of the functions moving backwards. So this is how it works. This is your network. You calculate the error, and on the basis of the error, the weights are updated, and those updated weights will be further compared with the error. And if it is not there, then your model is ready for the prediction. So if the error is below your tolerance, then your model is ready for the prediction. So combining this forward and the backward propagation, you are making this is making neural network to make predictions and more correct and precisely and based on the error functions, right? So over the time, these algorithms become gradually more accurate. If you'll see, if I just tell about that, whatever this loss function, error functions, they have changed. Your training pattern has changed. Okay, it has also improvised. A lot of things has happened now. Okay, if you just let me give an example about UNIT. Earlier, if you are able to recall, there is some network is there. It is just learning in a sequences. Sequential networks were there. Now there are UNIT is there where actually it is not taking from the earlier stage, but it is taking to the earlier to earlier stage also. Taking the input data from the earlier to earlier stages also, old stages also, and based on those data, it is trying to reconstruct the data, or it tries to balance the data. So that is what exactly is happening now. So that what is the meaning of telling all you things that the present deep learning algorithms are more efficient, and they are able to, they are not they are developing the intelligence in a sequence. Okay, in a sequence, they are not just only extracting the features and learning from those features. They also checks the intelligence developed by that features, whether those features are developing the intelligence or not. It is checking that while doing the training. Like there is, let me give one of the regularization method, that is a dropout. Okay, in the deep learning there is a regularization method that is called as dropout. It actually drops the neurons, those who are not contributing to the development or improvisation of the performance. So ऐसे जो neurons है जो contribute नहीं करता है, it is automatically dropping those neurons. So that is what I'm telling. It is very much, if you see the present status of the intelligent computing, it has been enhanced to a very large extent because of the deep learning, right? Okay, now let's quickly, I know many of you know about the supervised learning, unsupervised learning, reinforcement learning. So I'll skip this part and I will go to the next slides because I have a very less time providing you this, going through this presentation. Yeah, yes. When the deep learning started, people had started it for the images. Okay, scientists started it for developing for the images, because in the older time, when the whatever the artificial intelligence algorithms were there, they were actually used for the features extracted from the images. So what are those features? Those features are nothing but the some numerical values and the vectors, matrices of those numerical values. Okay. So though from that the images were actually learned. So that was a very poor learning of style. So that is why scientists were in a search for developing the algorithms, artificial intelligence algorithms, which can learn from the images. And from that, they have proposed first deep learning algorithm, that is convolutional neural network for the images. And it is a very basic DL architecture that is everybody is now aware about. What exactly the CNN does, it captures the spatial as well as temporal dependencies in an image. Now, this is very important to understand. If you look back into the earlier, before to the deep learning algorithms, this spatial and temporal dependencies were not able to capture. Let me give an example. Agar aap logo ko yaad hoga, some people here present in this session may know that we used to take the intensities, pixel intensities as an input. हम लोग पिक्सल इंटेंसिटीज को लेते थे और उसके कुछ फीचर्स कैलकुलेट करते थे, राइट? इंटेंसिटी एक फीचर होता था, कुछ और फीचर्स कैलकुलेट करते थे. सो वी वर नॉट टेकिंग द स्पेशल एंड द टेम्पोरल डिपेंडेंसीज. स्पेशल इन द सेंस उस पिक्सल के सराउंडिंग जो पिक्सल्स है उसके साथ उसका क्या रिलेशन है, ऑल दैट थिंग्स, रिलेशनशिप्स वर नॉट बीइंग काउंटेड. उस स्लाइस का, उस इमेज का उसके बाद वाली इमेज के साथ या उसके आगे वाली इमेज के साथ क्या रिलेशन है, that temporal dependency we were not counting in the earlier time. But now with the CNN, with the deep learning, this both the temporal as well as spatial dependencies were being counted very nicely, right? So that is being counted by designing the relevant filters. We have to design some relevant filters. You can see here, this is an image of the car, and this is the relevant, these are the convolution filters are here. So these convolution filters will be taking the patch of this image, and this patch of the image will be convoluted with this filter, convoluted. And after the convolution, whatever the information will be extracted, that will be the features of that part of the image. And likewise, the features will be extracted by this convolution process from all the patches from these images. and those data, those features will be then taken forward to the next layer, that will be given to the ReLU function. ReLU function is nothing but your activation function. Okay, this is most widely used activation function in the deep learning architecture, that is rectifier linear unit. So it will be taking all that features and it will be taking the decision, okay, what to do next. And after that ReLU function, whatever the information feature map will be generated, that will be going to the pooling. Pooling is nothing but it will be actually reducing the size of the features. Okay, it's just like what we do in feature extraction and the feature selection. We extract the dominant features instead of taking all the features, because counting all the features, it is very large. So instead of that, we will be taking the dominant features. Okay, or we will be taking the representatives of that dominant features. Instead of taking all the features, we will be taking the representatives of those features. So that is nothing but the pooling. So it will be reducing the size of the feature map from larger size to the lower size. So that is done by the pooling here. So it will take this patch and then it will reduce the size. You can see here the size of the feature map is reduced now. So this reduced feature map will be given again to some another convolutional layer. So what this convolutional layer again will be doing, it will be extracting the now earlier convolutional layer has extracted the low level features. This will be extracting the medium level features. Then again it will be done the pooling activation, then pooling, then again it will be having, it may have some another convolutional layers, then again it will be extracting further fine features, or I will say high level features. So you can put up more than one convolutional layers, or the purpose of putting those convolutional layers is that to extract the features, right? So that will be done, and after that in the last stage you will have this fully connected flattened layer, fully connected layer, softmax layer. Okay, let me tell you about step by step what these layers are all about. As I told you, convolutional layers, it actually has the weights and it handles the small regions. It extracts the hierarchical features. As I told you, low level features, high level features, okay, medium level features. You can see these are the edges and dark spots. These are nothing but the low level features. These are the eyes, nose, ears and noses. These are my medium level features. Then the faces, the complete face, these are my high level features. So this is how the convolutional layers will be extracting the features from the data in a steps. Now what is this convolution does? This is your kernel. This kernel will be convoluted with this input matrix like this, and it will be generating this output matrix. So you can see this 7 by 7 matrix is reduced here to 5 by 5 matrix. This is your feature map. This is your feature map, okay, which is having the values of the features here, right? And then there is the activation function. As I told you, ReLU activation function, rectifier linear unit. What is the advantage of this? It introduces non-linearities to the decision function, and it is important thing is that whatever the non-negative values are there, it actually omits those values, right? Non-negative values indicates that those neurons or those features are not relevant. So it will be automatically eliminating those properties and taking the better features ahead. Okay. So earlier, what other functions that are there, like TANH is there, and leaky ReLU is there, and ELU is there. All those functions are there. Pooling layer, as I told you already about this pooling layer. See this from this matrix, instead of taking this 12, 20, 8, and 12, it will be just taking maximum of this. So I call it as a max pooling. Okay, it's not only max pooling, there is average pooling is also there. Okay, so most widely used the max pooling is there. So maximum value will be taken here. Instead of taking all these 4 values, the maximum value from these 4 values will be taken here. Okay, so this is a max pooling and this is the average pooling that is done. Then flatten and the fully connected layer. This is very important. At the end of the network, you will find these layers. Now, what is the purpose of flattened layer? It converts the high level feature map into a column vector. Okay. So there will be a map, 2-dimensional data will be there, and it will be converted into the column vector for the APSI layer, fully connected layer. Fully connected layer is just like you have seen in the neural networks, where every neuron is connected to the neuron in the another layer. That is what is fully connected layer. So you will be having a fully connected layer. Fully connected layer learns the non-linearity combinations of the high level features. it learns the non-linearity combinations of the high-level features as represented by the output of the convolutional layers. Okay, so this any ordinary neural networks, each neuron in this layer will be connected to all the number of neurons in the previous volume. That's what I was telling you about, right? So after this, it will perform. After the fully connected layer, the classification task will be performed by this fully connected layer by using either sigmoid function or by using the softmax function. Okay, so sigmoid function we generally use when we are doing a bilinear classification, and if you are doing a multi-class classification, then we go for the softmax, where the probability is actually calculated for the output features. Okay, final features generated by the fully connected layer. It generates the probability values in the range of 0 to 1. Okay, so whatever the outputs will be there of the softmax layer, that will be the outputs desired by you, desired by the user. Say that I want to classify my data into the 4 classes. Ultimately, I'll be having the 4 outputs in my outputs in my softmax layer. Okay, so for that 4 outputs, after fully connected layers operation, it will be generating 4 probabilities in that output. It will be indicating me that yes, this particular output is having the highest probability. It means that yes, this is a car. Okay, and this is not a car. Okay, so that is what exactly will happen. So this is the function of the softmax. This is the function of the sigmoid. Okay, yes, let me just give you the brief about the evolution of this deep learning. As I told you, this is the first CNN. CNN is the CNN was developed in the beginning of the 20th century, and after that it has then developed. People have started developing AlexNet. Then ZFNet is developed in the year 2013. NIN, Overfit, VGGNet. People then moved GoogleNet, fully convolutional network, recurrent neural network, residual network, segment is there, segmentation network, UNet, fractionalate, YOLO, SSD. If you see this is all just in the period of 6 years, so many deep learning networks has been developed. And if you just look at these different deep learning architectures, they are having a very unique abilities. Like UNet is developed for the segmentation, image segmentation, detecting an object in an images, right? For the classification, for learning, for predictions, recurrent neural networks, right? Those were developed. Residual networks, they are able to learn from the residuals, right? So there, if you just look at these algorithms, you will be surprised to see that as per the application, major applications, like you want to identify an object, you want to classify some particular data, one-dimensional data or two-dimensional data, you want to predict something, the deep learning. So since 1950s, people have done different tasks, different application tasks like prediction, classification, detection. They have taken so much time, but with the deep learning, you will just see in the period of these 6 to 7 years, people have redeveloped all those applications using the deep learning, and that are most successful. You have an examples with you like AlexNet. What is that? You have in your mobile phones, right? You have Alexa, right? Alexa, that is, what is it? It is deep learning network. It is able to identify what you are speaking. It identifies you. It detects your speeches. Okay, and according to that, it makes you available all the data from the internet services. That is how exactly it works. So these are the advantages, as I told you already. So I will just go ahead. Now, there are limitations. We have to just think about this one. As there may be many budding researchers here, you have to always think about these limitations while designing your DL architectures. First thing is that learning through observations. You have to have that, what was in the data. You have to understand this. You also have to talk about the issue of biases in selection of total hyperparameters. This is what is very important. People say, ask me many times that, sir, how do you decide these hyperparameters and everything? So let me tell you guys that when you design any deep learning architectures, while designing its hyperparameters in the sense what weights you have to take, what size of the windows you have to take, how many convolutional layers you have to take, how all that things, what functions you have to take, okay, why should be the size of the pooling is there. This all you can do or decide based on your experience. When you will be designing the different DL architectures, then you will be automatically able to decide it. Like if you ask me that if you want to, sir, if you want to detect something on an image, what network you would like to prefer, I will say that yes, you go for the unit, right? So with that, you have to understand that requires large amounts of data, powerful and accurate models are required, more parameters are required. You also require theoretical foundation. No strong theoretical foundation is needed because computer will be learning on its own from the data, only data, right? Then there is only one specific problem. Deliver deficient and accurate solutions, but only to one specific problems. This is what you exactly have to do. If you'll see AlexNet and everything, ImageNet. ImageNet is actually designed for detecting the images. I detect the images of many things, like detecting the image of the cat, detecting the image of the fruit, detecting an image of different animals, right? So that is a different task. You have to focus on deciding on one task, like we are doing now, that we are trying to detect one particular type of tumor in a healthcare, right? So that is what exactly you have to do. And while doing that thing, there are many challenges involved, and you have to deal with those challenges while designing your DL architecture, right? So that is the most important application of intelligent system, that is intelligent healthcare, and the related to our theme of this our faculty development program, that is intelligent healthcare. So let me come to that intelligent healthcare. First thing comes into our mind that why we are playing with such an insensitive area with the intelligent computing, right? Many people ask me that why we are putting the computers into the healthcare, right? Let me tell you the reason. First reason is that in the present time, the computers are now they are become reliable, consistent. They are able to handle larger data. They are very good. They are now a reliable systems become. First thing. But second, very important thing is that why we have still allowed it. Okay, though it is in a poor, it is still not that developed. Okay, to take over the human intelligence or to but why we are allowing it, the most important reason is that if you will see the doctor-patient ratio and the today's time in India, it is 1:2000. Means for 2000 patients, there is one doctor. Okay, one doctor. Now just imagine that one doctor, how much time that one doctor can contribute to one single patient? Very less time. And that is what is the reason, we healthcare systems are designing. We are trying to design assistive technologies for the doctors so that they can do their task. They do not waste time in doing the smaller tasks. Okay, those can be easily done by the computers. We are trying to develop those assistive technologies for them so that they can, with the help of that assistive technologies, they can quickly treat their patients. They can quickly treat as much as patients possible. That is the reason. That is the reason it is allowed, it is accepted, it is growing in a very faster manner in the healthcare. Okay, now this is the reason that yes, allocation of the medical resources, improve the usage of the medical resources is limited, right? So due to that, intelligent computing, we are able to we are able to improvise it, right? Yes, if you see the whatever the human resources or expertise, healthcare experts are there. If you see the cost of those experts, the cost required in designing the assistive technology will be less compared to that. Okay, and that's why whatever the intelligent healthcare is there, it is cost effective. Okay, and like there is one system we call it the telemedicine. There's a new system of intelligent healthcare where what happens that the doctor patients can they can be at a distant places and they can communicate. They can patient can describe their symptoms. They can be they can be diagnosed, or they can be they can be actually you can scan those patients, provide those data to the doctors on a by using internet services, and those data will be understood or learned by the doctors who is sitting at a long distances, and from there he is giving an opinion, or he is giving a he's doing the diagnosis and treating the patients. So that is a telemedicine. So that sort of intelligent healthcare systems are being developed. Intelligent wearables are there. Nowadays, you people are wearing intelligent watches, which can measure your blood pressure, which can measure your heart rate, which can measure your temperature, which can measure your oxygen level. Okay, so all that things are now being developed by the scientists, engineering scientists for the healthcare, right? So AI in healthcare. Now, this is important part of mine where I would like to focus much, right? AI in healthcare is it is actually it is what does it mean? It is to describe the use of machine learning or deep learning algorithms or artificial intelligence to mimic human cognition in the analysis, presentation, and comprehension of the complex medical and the healthcare data. Now, let me tell you about this. When I say complex medical and healthcare data, you have to understand, many of you goes to the hospitals, you see that, right? Doctors take MRI, CT, and so many. For one single scan, they measure they capture thousands of images. You see, you just understand how huge data that it is. To scan, to understand, analyze, present, and comprehension. Say that you are doing one scan. Say that intravascular ultrasound is being captured. So you have to do a complete procedure of sending. First, you have to find out the artery. You have to send the catheter inside it. That catheter then is withdrawn gradually by an expert. And while gradually withdrawing that catheter, it will be capturing the ultrasound images. For one scan, it captures around 2,000 images. And then radiologist will sit and see each and every image. And on the basis of that analysis, and he will create one presentation that, yes, I think I found something like this in this particular artery. Okay, that is what how the AI, that is what exactly the manual work is there. And it is about with the help of the artificial intelligence, we can provide them automated intelligent systems which can do this task automatically, and due to that, we will be able to save a lot of time of the medical practitioners. That is what is important. So the prime aim of health-related AI application is to analyze relationship between the prevention or treatment techniques and patient outcomes. Okay, first we have to say that we have to see the effect of the treatment. We have to automatically make the doctors understand what is the effect of the treatment, what is the treatment can be given, what is the effect of the treatment. Okay, and means what is the diagnosis, that the patient is suffering from what kind of problem. So all that can be given by using the AI application based healthcare systems, right? So very popular is the diagnosis process. If you will ask me what I am doing in this area, I am doing majorly the diagnosis task. Yes, I am taking the medical data, I am doing the diagnosis. I am trying to develop the computer-aided diagnosis systems which can automatically diagnose the disease in the medical data. Okay, that is what exactly I am trying. Okay, and if you will see, majority of the research in AI, majority of the research of AI in healthcare is focused surrounding this. Okay, because it is a very tedious, very important task in the healthcare, that first of all, you have to diagnose the patient. Once you have diagnosed the thing, then next of the things can be done. Okay, then doctor can design a treatment, then the treatment effects can be analyzed, okay, automatically. But you can allow an error in many other things, but you cannot allow the error in the diagnosis. That is very challenging task. Okay, and if you see the medical data available in the like MRI or CT, or if you see, those data are very challenging data, because there is no ability in that data to distinctly the uh, show the show the disease part. Okay, I will show you some examples related to that, right? Yes, there are AI algorithms which is used to analyze large amounts of the data through electronic health records. Also nowadays, if you see, there are AI applications in analyzing the health records. Also, it is also AI softwares are used to support operational initiatives. That if you are doing some surgeries or some operations are being performed by the medical experts, the AI is providing them assistance, providing them some like doing some robotics. Okay, and doctor just giving instructions, and robot is automatically performing an operations. Okay, and it is also able to improve the business operations, like increasing the utilization and decreasing the patient boarding, reducing the length of the stay, optimizing the staffing levels. In all that related areas also of the healthcare, the AI is playing a very critical role. Okay, so what are the implications of applying this AI in the healthcare? Yes, we are able to reduce the medical costs by using AI-based BCIs are being actually developed to help the patients to move and communicate by the decoding neural activities. Okay, so this is making them more productive. Patients are able to communicate more. They are able to describe their medical conditions better, in a better way, to the doctors, and due to that, their treatments are getting improved. Right? AI also led to significant improvements in areas of healthcare. Hello, conclude that. All is you are able to hear me? Huh? Am I audible to all?
Yes.
Yeah. Okay. Okay. So I have received a call, and from the organizers, they want me to conclude, because as I'm running out of time. So yes, with this introduction, I think you will be having a great time in this program. Okay. So even I will share this my presentation with all of you, and you people can have a look at this complete presentation, and you will have a good idea about this one, right? So I will just quickly go through the slides just to show you what me and my team is doing regarding that diagnosis of the diseases, right? How we are using these AI tools. Okay. Uh, so this is basically application areas. If you will see, the AI applications are dermatology, radiology, screening, psychiatry, then primary care, then this is diagnosis, telemedicine, electronic health records, precision medicine, drug interactions. Okay, ambient assistant living. This is very now appealing area to in today's time. So we'll see, we have just captured the companies, those who are actually participating in these applications, and we have placed here this on this PPT here. Okay, this is prepared by the Tech Burst, and we have taken with their permission here, and you can see there are a lot of things that has been done in the healthcare by using the artificial intelligence. Okay, so as I told you about some of the application, precision medicine, as I told you. So it is actually the system which is actually helps to decide precisely the medicine to be given by the for the patient. So if you see the see here, it is automatically detecting in this image. You can directly come to this image and see here. It is detecting the tumors nodules here, and if it is having the less than 3 centimeters or it is in the range of the 3 to 5 centimeters, then measure and integrate the omics in bio specimen. So it is indicating that you go for the physiological test, biopsy test, and in that it is trying to find out whether it is high risk or the low risk. And if it is a low risk, then it will say observe by the doctors. And it is high risk, it is telling that adjuvant immuno and chemotherapies will be assigned to the doctors. So this is an automatic system. Okay, it is doing all this analysis task here automatic way, and it is then only it is saving the time, lot of time of the medical practitioners to decide on the medicine, that what medication to be decided for the diagnosed patient, right? Then there is a AI and medical visualization. A lot of AI applications are being designed in trying to find out disease part into the medical images. That is what exactly is the purpose of this application. Then intelligent personal health records, as I told you that whatever the health records, nowadays cloud-based systems are being prepared, and as I told you, telemedicine is one of the example of that, in which the health records are being prepared at one end, and it is being shared at different locations by using the cloud services, by using the internet services, right? So nowadays the records are being kept, digital records are being kept systematically. They are managed, okay? And we are also having the whatever the variables we have, from that also the health recordings are being health monitoring is being done. Let me give an example. I have one app in my mobile which is actually measures my sugar. So every time when I measure the sugar, when I measure my sugar, it is actually captured by that application. That application, what it does, it records my sugar, it records what I'm eating, it records what medication I'm taking every day, and on the basis of that, it generates one report, and that report I share with my doctor, and by analyzing that record, then he further decides and he informs me whether I'm going well with my medication or not, or if I need further medication, or if I need to do some precautionary measures for controlling my sugar. So that likewise there are such health keeping records. You will see this is a very huge area is there in the healthcare. Robotics and AI powered devices are there. As I told you about that, the people are nowadays, even the operations are being performed by the surgical operations are being performed by the robots, but based on as per the directives of the doctors, medical practitioners, right? Let me tell you that like intravascular ultrasound kind of thing is not being operated manually now. It is being operated automatically by using the robots. Then there is ambient assisted living. This is very important thing that I want to tell you, that people are now, patients are now being assisted with the assistive technologies, some ICT tools, which actually provides them the remote care services, remote caregiving services. Like say that if some patient requires some assistance, some medical attention, then it automatically generates some sensors are installed into in that room. Okay, some pictures are being taken, some accelerometer sensors are there. So if some, and then there is some ECG based systems are there. So if some abnormality happens into that particular parameter, it gives an indication to the doctors or the caregiving system or to the nurses that yes, this patient is suffering from some problem, just go and attend that particular patient. So this ambient assistant living based systems are being majorly developed nowadays, and a lot of research is going in this area. One of such systems that we also have developed. So these are the success factors of AI in healthcare, that yes, because of AI in healthcare, assessment of disease onset and treatment for success is there. There is a lot of success in management and elevation of the complications. We are able to reduce we are able to learn the complications very easily, and we are able to manage them now. Patient care assistance is possible because of the AI during the treatment or the procedure. Research aim at discovering or treatment of the disease is possible. So because of all these success factors of AI in healthcare, its application in the AI is increasing day by day, right? So this is again a summary that I have prepared for you, but yes, again, the time is running out of it. So I will skip this, and AI in near future is there also there, and these are some of the here research highlights of the team that we are working. Some of the highlights, not all of them, that we have recognizing this carcinoma, that cancer detection is there from the lymph nodes in the CT images. We are doing it, and we are doing it by the deep learning, and I'm happy to tell you that the success is very high in this our one application of AI. And I can tell you that the success is almost 90% has reached now. And if you see these nodules, these lymph nodes, these are very small in size. And if you see its appearance, is very similar to any other object available in the CT images. So finding that in the CT images is very challenging. Lung segmentation, we have done one research work on the lung segmentation, and in that also by using deep learning we have applied in on the different data sets of Luna, Vessel 12 and HUG ILD data set, and in all that cases excellent results have been received. We also are doing some psoriasis. This is some AI application based computer aided diagnosis system we have developed for the psoriasis disease as well. This actually based on the color images we captured from the patients, and we have developed a system based on the deep learning, which is not only detecting the psoriasis, but it is also telling that how much severe that psoriasis is, whether it is mild, moderate, severe, very severe. It is detecting that as well. So with that also, if you see the performance of our system, it is very high, and you can I can just tell you that it is reaching, it is close to 100% results are coming with this system, right? We are also developed some pain detection system, yes, because in healthcare system, this pain is very important and is very uncertain kind of thing. People are not able to gauge much on from the pain. People feel, doctors feel sometimes that how much anesthesia they have to give to the patients, and they either require a lot of experience, or they actually analyze based on the pain, that how the patients are behaving. So what we have thought, with that thought, we are now designing the intelligent pain systems. This is the first time that we are doing it across the globe. The psoriasis work is also the first time that we have done it in the world, and this pain detection system also we have done it. This pain detection system is also sponsored by the Ministry of Science and Technology, and with this also we have applied deep learning here, and in this system we are able to not only finding that whether the patient is suffering from the pain or not, we are also finding what type of pain it is. So if you will see earlier pain-based systems, it was just observing the patient. Earlier doctors used to observe the patients, that yes, just by observing his body movement and sound, and based on that they used to take the understand the problems and treat the patient accordingly. But now this system will be an objective method, and it will be helping the doctors to find out how severe that pain is, and accordingly the doctor can give their treatment. Yes, if you will see the performance here also, we are achieving a very high performance in these cases, right? And yes, we also have doing one. This is the first time somebody has developed a P300 speller based communication system. We have developed one communication system for the patient, those who are suffering from the neuromuscular disorders. With this communication system, the neuromuscular disorder, the patients can communicate to their doctors, their family, to their caregivers, and even though they are not having any neuromuscular ability, they can perform their task by just thinking, just by giving the signals from the brain. So we are recording the EEG signals here, and by looking at this alphabets, the communication, verbal communication, it's like just like somebody saying stop, STOP. So by measuring those EEG signals, we are creating those alphabets and combining those alphabets and forming one word, and combining those words and forming one message for the caregivers, for the doctors, for their family members. So this is one system, and we are doing it in the Devanagari, in our own Indian, for our own Indian languages. So that is one again we have done with the deep learning, and if you will see, the performance that we are getting here is very high, and it is ready for real-time implementation. I must say that. Yes. So with that, I thank you all for kindly attending my session. I thank all the organizers for inviting me. I hope that I have given you the best possible initial platform for going ahead into this faculty development program. I'm very sure that with this knowledge, you'll be having a great time in this faculty development program. If you have any queries, you can quickly ask me.
So,
I fully understand you must be now.
There are two questions from Dr. Nilima Kulkarni.
Yeah.
The first question is number of hidden layers fixed?
If you are talking about deep learning, no, you don't need to. Okay, you need to increase it. You, on the basis of your experience, you have to understand that how many convolutional layers you have to put up, right? Because when you will be getting to start your high level features, once you are satisfied with those high level feature map, and you starts to get the better performance, you can stop increasing your hidden layers. That is how you can do it, right? Anything else?
And how the number of hidden layers required is decided?
I told you.
Yes, sir.
That
Just
you have
you answered.
For this, there is a process of cross validation that we do. If you are doing any work on this area, that is what we do, cross validation. You have to cross validate your network by giving the data in a different manner. Say that you are applying 10-fold cross validation, so you will be making 10 parts of your data, giving 9 parts, and using 1 part for the testing. So while doing this cross validation, you actually play with your hidden layers, right? And once you will find the best performance, you can stop doing that.
Okay, so it is an experimentation process actually.
Yeah, yes, ma'am. Yes.
Yeah. Okay. Anyway, nice session and very nice work you are doing at your side in the medical domain.
Thank you so much, ma'am. Thank you so much.
Nice to hear. Yeah.
So there is another question
Yes,
from Vikesh Bodu. Sir, in case of less training data, how do we know at what point data augmentation should be stopped?
Yes, this is very important question. And the answer to that question is again in the same thing, right? You will augment the data, okay? Say that you are having only 1,000 samples. From the 1,000 samples, now you have increased the data, right? You applied one augmentation and you increase the data, and you made it 2,000. Now again with that 2,000, try to find out the performance of your system. Fine tune your hyperparameters, and once you are done with the hyper tuning of your parameters and you are satisfied and you are now aware about the best performance of your system, then stop at that augmentation, and you see that whether that performance is acceptable to you. If it is not acceptable, then you go for further augmentation, right? I don't have a time, otherwise I could have shown you. Just let me show you one slide here. If just allow me show you this slide.
Like sir, like when I was doing the same data augmentation on similar data set using the GANs, so I was not able to get proper images, sir. Like all my images are completely blurred.
You can see this. This is an augmentation work that we have done. We were having only 271 images. From these 271 images, we were getting an accuracy of 61% only. We increased this data size and made it 1897. We have further increased our performance and increased to 79%. We again increased our data size by using further augmentation 2168. Our performance has increased to 89%. We further increase again with the dot augmentation 2439. My performance is now starts to get consistent. Here my performance starts to get same. And again I further applied some another augmentation method and I increased my size to 2710. My performance is 87. Then again I increase it by using another augmentation, my size is 4065 and my accuracy is coming close to 90%. And there I am now. After that I found that yes, after this there is no point in increasing the data size because my model's performance is now stagnated, it is now coming constant. That time I stopped my augmentation and thereafter I just done with the augmentation. So this is how you have to work with the augmentation as well. See, finalizing one method is not that easy for deciding on the augmentation also. You have to perform many experiments. Okay, first experiment you have to perform with the augmentation method. Second, you have to perform the experimentation with the tuning of your hyperparameters of the deep learning architecture. And with those two experimentations, you have to see where you are achieving the best performance, and that will be the best augmentation combination, and your DL architecture will be there, which will be fit for your application. Okay, why you have to need all this to perform? I have to make you clear this one DL architecture, even though it is a unit, say that you are tuning your unit, or simple unit also. That tuning, that configuration will not fit for from one application to another application. Say that it is fit for lung nodal detection, it will not fit for detecting the lymph nodes. It will not be. You have to change it for your applications. You have to fine tune it for your application again. Okay, so that is what exactly you have to do. You have to do a lot of experimentations about it. Okay, anything else, Priyanka?
Yes, sir. Sir, one more query is there that whether they should choose five-fold cross validation or tenfold cross validation.
I will suggest if you are having a good computer, right, and if you are handling image data, graphical processing units are there, go for higher folds, because higher folds gives your DL architecture more better learning, because your similarity in the folds, in the sense you will be increasing the folds. So increasing the folds, say that in one fold 10 data are coming in 10 folds. So the correlated information in that 10 data will be learned by your DL architecture. While in case of 5-fold, it will be having the 20 data in one thing. So 20 data, interrelated information between the 20 data will be small, or it may be inferior. So it is better that if you can increase the folds.
So there's a last question.
Yes.
That what are the various challenges of skin diseases which can we do in future research?
Yes, there are many challenges regarding this. I can tell you, dermatology is something where there are many diseases. Melanoma is there, psoriasis is there. There are many such diseases are there. Okay, and right now, if you see one thing, the people, those who are interested in this topic, I would like to tell them that I am having a very big challenge when I'm doing my research work on psoriasis. If somebody is having more than one skin diseases, how I can develop my system for detecting one disease? That is a challenge for me, and I'm working on that. So though I have not found any patient yet, those who are having more than one skin diseases, but it is expected. See, skin is a very difficult thing. Skin changes from person to person. It changes from location to location. It changes from race to race. It changes from gender to gender. For humans, and even we can think to apply it on the animals as well. So this is a huge thing. There are a lot of research scopes in the dermatology, and I can surely guide on this. If you want to discuss further, you can just get in touch with me in person, and we can further discuss about it. Anything else?
Yes, sir. So that's
Yes,
for all
we
further
need to have a
questions.
break, and thank you once again. Yeah,
So
my
thank
mail
you so
ID.
much. Sir covered the topic Introduction to Intelligent Computing and its application in healthcare. Very nicely, sir covered this topic, and I hope all the participants have gone lot of experience knowledge from sir. Thank you so much, sir, for your valuable time.
Thank you, Priyanka. Thank you, Mridhu Sahu. Thank
Thank you,
you,
sir. Thank
Bhupendra.
you, sir. Thank you so much,
And
sir.
thank
Actually,
you, Head of
because of
Department IT, Dr. Tripathi, for inviting me. And most importantly, that allowing me to keep the foundation for this FDP program with the inaugural talk. And I'm very sure with this thought, with this knowledge, they will have a great time in the coming in all the coming sessions. Thank you so much, and
thank you,
all the
sir.
best to all the participants and the organizers too.
Yeah, participants, if you have any query, sir has given you his email ID. You can contact to him also. Okay. Thank you so much, sir.
Yeah, because of time issues, we are not taking any break right now. We are proceeding for our next session. So I would like to welcome our next speaker, Dr. Vikesh Kumar Singh. Dr. Vikesh Kumar Singh, PhD, sir has received his doctorate degree in biomedical engineering from National Institute of Technology, Raipur. Sir is currently working as assistant professor and head of department in the Department of Biomedical Engineering, NIT Raipur. He has more than 11 years of teaching experience and research experience. He has published more than 60 research papers in various international journals and conferences of repute. He is senior member IEEE, life member of IE, IETE, and CSI India. He has received IETE Gauri Memorial Award in 2016, IEI Young Engineers Award in 2012, Chhattisgarh Young Scientist Award in 2010. His research interests include medical image processing and analysis, biomedical signal processing, soft computing, and machine learning. So, I